Welcome everyone to today's webinar for MTM Critical Minerals, ASX code MTM. Shortly, I'll introduce CEO Michael Walsh, who will provide an update on the company's progress with its flash Joule heating technology, including recent advancements in lithium recovery from spodumene. At the completion of the short presentation, Michael will also be on hand to answer any questions you may have. Now, these can be submitted via the Q&A button at the bottom of your screen at any point. So during the presentation, think of your questions, write them in the box, and I'll put them to Michael at the end of the presentation. Right, let's get into it. We've got a big crowd and they're waiting for the MTM Critical Minerals story. I'd now like to introduce CEO Michael Walsh. Michael, over to you.
Thanks, David. Good morning, afternoon, everyone. Thanks for joining us today. Yeah, we're excited to present our latest developments and the potential of this flash Joule heating technology, which we believe is a game changer in the critical metals recovery sector. Next slide, please. So from a high level perspective, our vision is to become both a leading supplier of technology to the global metal recycling and extraction markets, and also potentially a leading supplier of sustainably produced metals from waste streams and ores, thus having two possible income pathways with several business model opportunities therein. And we aim to achieve that by the flash Joule heating platform, which is a breakthrough technology. And we're essentially trying to solve the problem that traditional processes like pyrometallurgy and hydrometallurgy have with metal recovery, which is that they're expensive, energy intensive, and very reagent intensive, but also non-selective, meaning that they don't just target the metal of interest, they also pull out all the other metals as well, which therefore then need to be removed. Next slide, please. And the flash Joule heating technology, what is it? Just from a high level perspective, it's an advanced and patented, very fast heating platform that enhances metal recovery and mineral processing compared to traditional methods. By rapidly heating the materials in a controlled atmosphere, we can efficiently extract metals from refractory minerals like lithium from spodumene and from e-waste, etc. So the potential here is to revolutionize how metals are recovered by reducing the energy, reagent, water consumption, etc., and ultimately offering a more economical and environmentally friendly alternative. Now, the simplistic diagram here shows that it's an electrically heated system. So we can use both solar energy, wind energy, small-scale nuclear power, etc. for the energy. We're not reliant on fossil fuels like a lot of the incumbent technology like kilns are. Next slide, please. And there are, from a high-level perspective, there are two main verticals we're going after. So metals from industrial waste streams and also improving the processing of refractory minerals. On the industrial waste streams, we have waste such as black mass from the spent lithium-ion batteries, where we can selectively pull out the valuable metals like lithium and cobalt. And then there's also high-value e-waste, where we can target gold and copper, etc. And then more along lines of our recent announcement is that we're trying to improve how refractory minerals are processed, and in particular lithium, but also rare earths and soon niobium as well. And now refractory basically means it's very challenging to extract. Next slide, please. And the latest announcement that we have this week pertains to lithium. And why were we targeting lithium flow sheets? Well, it's a common, when you're in the industry, it's a common problem that lithium is a very, very refractory mineral. Spodumene is the world's dominant source of lithium currently, and the traditional flow sheet was developed about 70 years ago, and that flow sheet uses what's called calcination and roasting, both consuming very high amounts of fossil fuel derived energy and therefore emitting a very large amount of carbon dioxide. Now, the flow sheet also requires a significant amount of acid and other reagents due to the impurity removal steps required, because within the spodumene mineral, there's not just lithium, but there's also a host of other what are called gangue or waste metals. And as you can see from that photo, it's pretty obvious that it involves a very large capex and operating cost. Next slide, please. Here's a very simplified flow sheet showing how spodumene concentrate is currently refined in those flow sheets. This is a lithium carbonate flow sheet where the battery-grade lithium carbonate goes into a lithium-ion battery. Now, it's called the sulfation roast flow sheet, and it's been around for about 70 years. And as you can see, it involves a lot of fossil fuels and acids to achieve your battery-grade product. Next slide, please. Now, just to put some numbers on it now, including the mining of the ore, blasting, crushing, etc., 50% of the total energy you need per ton of finished product goes into that single calcination kiln. And that involves cooking the material at 1100 degrees for 3 hours. And the only source for these horizontal kilns is fossil fuels currently. So that's a lot of fossil fuels, it's a lot of CO2. And not just the calcination step requires lots of energy, also the acid roasting, where you basically roast the lithium in an sulfuric acid environment to turn it into lithium sulfate. And then the subsequent steps involve pulling out the impurities from that lithium sulfate. So it's a very energy intensive and reagent intensive process. And the kiln is the dominant heat transfer medium used here, and that kiln technology has been around since the Bronze Age. So it's not exactly new technology. Next slide, please. So what have we done? So we've essentially gone from that same spodumene concentrate feedstock directly to a saleable product in one single step. Now, I think that should be underlined, really, that we've gone directly to something that we can sell in the market in a single step using this flash heating technology in a chlorine environment. So that really is a potential game changer for the industry. And next slide, please. Now, it is truly a saleable product. You can see from this slide that just checking the Albemarle website, Albemarle are the Western world's biggest lithium chemicals provider, and they've got several lithium chloride products for sale. So it is a genuine saleable product that we've produced from raw spodumene concentrate. Next slide, please. And now to turn that lithium chloride into the finished battery grade product, it's a very straightforward process in theory, just adding sodium carbonate to convert the chloride to lithium carbonate. So essentially, we can go to direct lithium carbonate battery grade product in just a very small number of steps. Next slide, please. And here kind of puts it into perspective. We chop out a lot of the CapEx and OpEx intensive steps from the incumbent Chinese-based flow sheet. So predominantly, I think about 90%, if not more, of the world's lithium is refined in China. All of the IP really resides in China. And this technology offers a solution to have an alternative means of processing lithium in, we hope, a much more economic and environmentally friendly manner. Next slide, please. And then from a conceptual level, how does it work? Well, refractory really means that the target metal of interest is locked. And in this case, it's locked in a glass type gel, or what is it really a tight bond. So spodumene is an alumina silicate, and the lithium is bound strongly to the silica in a glass type formation. And that's why you really need a chemical sledgehammer to get it out. That's why you need to bake it at 1100 degrees for 3 hours. And the novelty of the flash technology is that the rapid heating, so going from ambient to over 1000 degrees in milliseconds, seems to break that glass and break that silica lithium bond, and therefore liberating the lithium. And therefore, when you add chlorine into the mix, the lithium readily reacts with that chlorine. So you're essentially distilling off the target metal of interest and leaving the unwanted stuff behind in a very elegant and efficient process. Next slide, please. So just to summarize and underline what we're talking about here, we've gone to a direct saleable product in a single unit operation versus the very complex and costly traditional flow sheet. We've not used any strong acids or bases, which the current methods require. We've got potential major savings in energy, OpEx, CapEx, and CO2. We will quantify all of those as we progress towards various study phases. So this is really a game-changing potential for the lithium refining industry. And we've already got interest from several major chemical and mining companies regarding potential technology testing and collaborations. So lots to watch out for in that space. And this type of operation really could mean that we can onshore a lot more of value adding in Australia or the US. And it also offers potential local production opportunities, especially even for deposits that might be too small to be commercial in the current environment. So yeah, lots to watch out for in the space. Next slide, please. And then just some upcoming catalysts in 2024. So we're going to be very active and busy for the remaining year. We've got the demonstration plant, which is a 1 ton per day unit that we're currently designing. The design is well and truly underway. We've got potential news on strategic collaborations. I already mentioned we're talking to various big players in the different verticals that we're targeting. And as soon as we can update the market there, we will do so. We've also got lots of work underway investigating non-dilutive funding. So there is lots and lots of grant funding, both from the US and Australia for technology like this, because it's all about onshoring, it's about critical metals, and it's about new technologies for reducing environmental footprints. So there were various buckets available for this type of technology. And we were in Canberra last week talking to various departments. And it's also worth noting that the Department of Defense and their offshoot research arm, DARPA, already have put in a couple of $1 million into the flash Joule technology from the original Rice University in Texas. So we've got the interest of the likes of the Department of Defense in the US, because they see the potential for this technology to pull out certain very valuable metals from scrap and also become less reliant on unfriendly countries to the US. And then there will obviously be ongoing test work, news flow, as we progress. So we've got work underway with other refractory ores, not just spodumene, but also rare earths and niobium. We're also looking at some high value e-waste, so pulling out valuable metals like gold, copper, etc. from e-waste. And there's also work underway looking at bauxite residue, which is a major environmental hazard here in Western Australia and other places in the world. And what we're looking to do there is recover alumina and titanium. So there's lots of news flow to come over the coming weeks, and we're going to be very focused on basically making this technology commercial as soon as possible. And that's pretty much it for the slideshow today, David.
Thanks, Michael. As I said at the beginning, there's a big crowd and there's lots of questions, so we might just jump straight into it if that's okay. One question, can this technology be used for processing lepidolite?
Yeah, look, we haven't tested lepidolite, but in theory, yes, certainly lepidolite is quite chemically similar to spodumene, and lepidolite tends to be lower grade than spodumene, and it's mainly processed in China at a very high environmental kind of footprint. It involves the use of very nasty acids and chemicals, and also because of the low grade nature of the ore, it's in the current environment, at least, they're sub-economic. So I think we've definitely got an opportunity here to try and distill the lithium directly out of that lepidolite matrix. So it's certainly worth testing, and it's already on our radar.
This is probably a question for me more than you. Can you explain the technology in more simple terms?
Yeah, so from a very, very simple perspective, we're heating a material in a very rapid manner, and that rapid heating causes a very beneficial chemical change to the target metal of interest. And I mentioned for refractory metals like spodumene and monazite rare earths, it breaks open the refractory glass that's encapsulating the target metal of interest. The rapid heating breaks that glass open and liberates the metal. And for the likes of e-waste, we can, using that chlorine environment, and there's other options, not just chlorine, but we can use the chlorine environment and the temperature control to selectively just pull out the metal of interest. We're essentially like distilling off the target metal by changing the temperature and the gas and leaving the unwanted stuff behind, because each metal will have what's called a formation temperature for its natural chloride. So every metal will have some kind of a natural chloride formation temperature, and we can, using that data, we can selectively pull out the ones of interest and leave the unwanted stuff behind. So it's ultra fast heating in a controlled chemical environment.
And you touched before on the key metrics and milestones. For you, what are the ones that you think will drive certainly interest in the stock and the value accretive announcements and news over the next 6 to 12 months? What are they, and what should investors be focusing on?
The biggest ticket item, I think, will be the 1 ton per day demonstration plant. So once we can achieve 1 ton per day type operation, that is almost commercial scale for some of the very high value waste streams that we're looking at, including the semiconductor scrap. And then another big ticket item will be the collaborations with major external companies that we can't name yet, but as soon as we can name them, that will be this external validation that the technology is actually worth. These guys have done the due diligence on the technology, and they're willing to collaborate. So the pilot plant and external collaborations with off-takers and partners, I think, are the two main ones. And then the ongoing kind of developments as we test other refractory metals like niobium, or try to recover gallium from semiconductor scrap, or antimony. So gallium and antimony are two metals that have recently been shut off in terms of supply from China due to the geopolitical spat that they're having with the Western world. So if we can achieve recovery of gallium or antimony from these waste streams or ores, I think that's also a big game-changing potential.
And there's a question here, I will name him, from Dinesh, who is firstly congratulating you on your appointment and what you've achieved since joining the company, and driven certainly the appreciation in the share price. His question is, how long do you think it'll take to get to a pilot study?
So yeah, hi Dinesh, good to hear from you. So we've got the current design should be finished at the end of this year, and we hope to begin construction of the pilot facility probably late Q1 next year, and it should only take another quarter to finalize, and we should be essentially in production by late Q2 next year.
Question here just in regards to IP. How locked up is the IP, and how does it limit competitors or others trying to do similar things?
Yeah, so it's fully patented, and each individual application will also be individually patented as well, such as the spodumene, which has already been done. It's a worldwide exclusive license, and the Rice University, they're very au fait with patents, and it's a high caliber type of team that were the founders of this technology. Dr. James Tour, he was also the behind the Weebit nanotechnology, which that went into an ASX shell company around 2016, and that's been a major success story. It's nanotechnology as well, and it's silicon memory chips, and that Weebit went to, I think, over $1 billion in market cap during the 2023 peak type tech frenzy that was happening on the ASX. So this comes from a high caliber team that knows how to protect its IP.
And in terms of the strategic discussions, I don't want to get you into trouble by naming people, although there's a lot of questions here from people asking you to. What does a strategic partner look like? Are they JVs? Are they at project level? Are they at company level? And how advanced are those type of discussions, and what sort of due diligence have they done?
Look, there are several ways to skin a cat in this regard. There are like licensing options where we can license the technology and get paid a fee, and also get paid a fee per ton of material produced. And then there are also like collaborations where, if for a very niche application, we could co-develop the IP together. And yeah, there are several ways to skin a cat, but we certainly, because we know the novelty and the uniqueness of the technology, we certainly won't be bullied into just going with whatever the bigger player tells us just because they're bigger. So it's there's a well-trodden path as to how to approach these type of things. And yeah, we certainly won't be bowing over to any of the big guys just because they think they're bigger. That makes sense.
Maybe a way of answering the question without naming names. The phone ringing, getting many calls?
Yeah, certainly. Yeah, I think most people can work out who the potential players would be in the lithium space and also the rare earth space. But then there's also US companies and South Korean companies on the e-waste side that are interested in the technology. So yeah, look, we're obviously bound by NDAs and things, so we will announce that as soon as we can.
And how do you mitigate risks associated with fluctuating metal prices, and market volatility?
Yeah, look, mining is a very cyclical space and can be brutal at times. And this avenue that MTM is pursuing, we essentially, we're avoiding the risk of mining and exploration by having, all the mining and discovery risk is already done. So your known quantity of metal is already in the materials you're after. And because we're agnostic to the metal of interest, we really can say pivot as the market changes for sentiment in terms of, say, gold or niobium or lithium. Like lithium sentiment is obviously poor right now, but we've got opportunities for gold, copper, which are not in the toilet right now. So the fact that we've got so many verticals to chase sets us apart and gives us that moat around the business, I believe.
And just circling back on part of a question or an answer that you gave a little while ago, another question that's come through is what specific rights do you have and what countries is covered by your agreement?
It's currently a worldwide license, and the license is specifically for all ores and metals except for graphite. So the original spin out of this technology was for graphene manufacturing. And that company is called Universal Matter. It's a private company based in Toronto. We visited the facility. They already have scaled up that technology to 1 ton per day. Gave me personal confidence to join the company because the 1 ton per day milestone has already been achieved. And they've got a very impressive facility in Toronto. So we've essentially, except for graphite, we've got all rights for all other metals, and it's a worldwide license.
And a quick question's come through. How big is that company?
It's a private company, but so I did hear some valuation that they've raised over, I think, 25 million US to date at a kind of a valuation of about 300 million. And they're aiming to produce, they are producing graphene for various applications like cement and coatings, which graphene is kind of like a super material. You add a small bit of it to like the likes of concrete, and it has dramatic effects on the strength.
There's quite a few technical questions come through from the same person, so I might try and get through as many as I can. What sort of quantity of lithium chloride was produced from what sort of quantity of spodumene?
So we haven't disclosed the actual recoveries yet because this is still proof of concept stage, but we're testing like 500 gram batches at a time, and we're getting our basically, I'll say this, our target is for 90% plus recovery. That's our target, but I'm not going to disclose what the current testing results are.
And what are the next steps to scale that up? And what sort of timelines are you working to?
So we've got a dedicated engineering team in the US, Nighthawk Engineering. They're a very credentialed company. They do a lot in the oil and gas space, and this is their sweet spot, scaling up high temperature like process engineering technology. And they have the design already underway for the 1 ton per day. And we've got regular updates with the team every week. And as I said already, the design should be signed off and finalized, we hope, by the end of Q4 this year, and then we can begin construction in Q1. And aiming to be in production for the 1 ton per day plant by the end of Q2. And that plant will be designed such that it can handle multiple feed streams, including the refractory minerals and also the waste streams.
Have you done any work on the differences in power consumption between traditional and your technology? What that sort of what that looks like? That's the question is there really some comparative numbers that are starting to form?
No, look, Dr. Tour has published from his lab scale perspective that the energy savings could be as dramatic as 1/50. But look, we haven't done any of that yet because essentially it's not optimized and meaning that we've got a lot of wasted heat with the current prototype testing because it's more about proof of concept rather than energy efficiency. So the 1 ton per day pilot plant will have all of the energy efficiency design parameters built into it, such as insulation and heat recovery. So until we have that actual data, we aren't going to be putting out any numbers to the market, but it should be substantial. Like if you just think about it for a minute, if you're heating a material for 3 hours at 1100 degrees, and you can do the same thing in a couple of minutes, and plus you don't have to do all the impurity removal steps, like it should be significant.
Can you talk to how this process looks like on a commercial scale? If the technology is verified to work at scale, what would that look like, and what kind of throughput capacity would that bring?
Well, so the 1 ton per day unit that we're designing is going to be designed in a modular fashion so that if we do need to scale up, you just basically bolt on another 1 ton per day unit side by side. And for some of the waste streams that we're looking at, like gallium recovery from semiconductor scrap, 1 ton per day is actually a commercial scale unit already. And that's the one that the Department of Defense are very interested in. We hopefully will be seeking out funding from the Department of Energy in the US for that gallium plant. And then on the lithium side of things, like we haven't sat down and worked out the economics yet, but I think even a 10 ton per day plant for a lithium chloride type development would definitely have positive economics. Considering that, like for our pilot plant, the capex isn't very large at all. Like we currently budget about $3 million US for the 1 ton per day unit in terms of the capital equipment costs. So this is very modest in the scheme of things, and hopefully these produce very high payback, high IRR, high NPV type propositions.
And another good one here. What is the opportunity for the company using the technology for lithium extraction?
Well, yeah, look, the opportunity are to get into production a lot quicker than you would for a typical refinery. The typical refinery, the permitting alone is a very long process due to the reagents that are needed, the tailings that are produced, the sheer power consumption, the fuel requirements. So with the permitting for something like a flash lithium chloride production plant, I would hope, is vastly quicker than a similar refinery. So we could get a semi-commercial scale unit up and running and generating revenue quite quickly, we hope. And as soon as we can partner with some of the bigger players and put the equipment at their site, I think that's when we can take the next leap in terms of scale up.
And what are the other minerals or metals that you're really focusing on at the moment? Obviously, lithium you've talked about, gallium and others. Is there a sort of path that you're focused on, or minerals and metals that you're sort of ticking off as you go that you're working through?
So on the refractory metal front, we're focusing on the well-known refractory metals, at least from a WA perspective. We're focusing on rare earths from monazite. And we also have recently got interest on the niobium front. So niobium itself is a very, very refractory mineral. Pyrochlore is the mineral. And we are hoping to go in the same manner here, go directly to a niobium chloride product from a concentrate. And that's next on our kind of bucket list to achieve. And then on the waste recovery side, we're looking at high value e-scrap, so pulling out the copper and gold from certain types of e-scrap. We're also looking at antimony, so we're trying to source some ore to see if we can recover antimony from some high grade antimony ore, because antimony, like gallium, it's another very, very ultra high value commodity right now due to the geopolitical situation in China and how they've recently cut off that supply. So we're going to go after high margin metals that we don't necessarily need to scale up rapidly to achieve big margins.
Question here, just on your own background, what attracted you to MTM and the opportunity?
Yeah, well, look, I've been about 15 years in this mineral processing technology space. I spent 10 of those years with the world's biggest provider of tech, Metso, previously Ototech. They're now the one company, but those guys have got the biggest market footprint in this space, and pretty much supply to all the metals. And there, I had a lot to do with scale up and getting new technologies into the big miners, who are generally very conservative in terms of taking on new technologies. They want to be first to be second. And so the real exciting thing here was, and I also had a lot to do with on the lithium front, and that's where I originally recommended that they test this technology on spodumene. And as soon as I saw the actual results, that's what gave me the comfort to change roles and get stuck into this, because I think the market here could be massive. And even Dr. Tour, the guy who, he's behind the Weebit company, he reckons that this flash Joule heating for metal recovery and mining is going to be a much bigger proposition than even his Weebit prospect. So another thing that gave me comfort was visiting the Universal Matter facility in Toronto and seeing that they've already scaled this up to 1 ton per day in a very impressive facility. So I think we've got a very short runway to commercial production. And it's an opportunity to try something new. Nothing really revolutionary has happened in the kind of heat transfer phase, heat transfer space for metal recovery for 70 years. Like the kilns have been around for hundreds and hundreds of years, and this is an opportunity to try to upset the status quo and make things more viable to produce in high cost countries like Australia and the US. So yeah, it's very exciting. It's very suitable and applicable to my background.
Just touching on that point you just made, particularly, with the US and North America and Australia, is there much government support? Do government look at this type of technology? And we talk about the critical mineral strategy and things that are happening. Does this play into those discussions? And is there support? And if there is, what type of support and when does it come for MTM?
Yeah, look, there certainly is. As I said, we spent a couple of days in Canberra last week talking to the various government departments in the resources space, and there was all the meetings were very favorable, and they were pointing it out. There's essentially 5 or 6 in Australia, 5 or 6 pots that we can immediately target for potential support, and those are about either onshoring critical metal supply in Australia or friendly countries like the US, or improving how the energy efficiency or environmental footprint of existing processing operations, and also making things more economical. So there's lots of money available for that. And then in the US front, there's even more available. As I said, the Department of Defense have already put $4 million into this technology via Rice University. And we're speaking to their offshoot DARPA at the moment about potential funding as well for a 1 ton per day unit. So there's lots of money in this space: critical metals, onshoring supply, and improving efficiency.
And in terms of the competitive space, do you compete with anyone? Who are your competitors, if anyone?
No, there's no real competing equivalent technology, at least to my knowledge. There are various methods of extracting minerals, but they all essentially use either kilns or fluidized beds, all of which they're very old and fossil fuel derived energy type technologies. But if you want to put some peer comparators in terms of companies, I think a very good one would be Hyperion X. They are a kind of a market darling on the ASX. They acquired a technology from Utah University. It's for recovering titanium from scrap. Very similar type of story. They've got interest from the Department of Energy and the Department of Defense as well. And that would be kind of a good one for investors to get their head around, who we are essentially trying to emulate. Now, there's other companies like Alpha HPA, Silex, and I think those are the 3 main peer competitors that would be kind of in the same space. They're mineral processing or metal recovery tech companies on the ASX.
Just touching on that, there's quite a few questions here around almost the way the business and the company is classified. Clearly, at the moment, you are classified as a resources company, a junior resources company, but with an emerging tech business. When do you think that switch occurs, and when do you think the tech investors will start looking at the company as a tech company rather than a resources company?
Suppose it'll all depend on our progress and how quick we can get into production on one of these metal opportunities. But we're certainly not abandoning our exploration projects. We're going to obviously keep those for the time being when the market does pick up for exploration again, and perhaps monetize those or progress them ourselves. But very complementary. I mean, we've got niobium tenements up in the Arunta. This technology potentially can recover niobium better than the incumbent methods. We've got gold tenements. We've got rare earth tenements. This is very complementary technology. But I think the majority of the funding for the time being is going to go into the technology development, and we potentially might monetize some of those exploration projects, but we're certainly not abandoning our exploration routes right now.
This may be a bit too ahead of time, but there is a question here around, have you started to look or think about the CapEx, OpEx savings on some of the projects when you're talking to some of these bigger producers, how that could start to play into the flow sheet and their own financial modeling?
Well, I think just from the conceptual level, the CapEx savings should be quite large when you consider that you're removing big CapEx heavy unit operations like ion exchange and calcination kilns and roasting kilns and all these reactors to remove impurities. So the CapEx savings should be significant, but we're certainly not we're going to try as much as possible to use basically either grant funding or collaboration funding from these bigger players to fund the majority of the CapEx, and not using our balance sheet to fund those. So that's at least the plan. And as mentioned, there's already lots of funding initiative underway there's loads of grants available for this type of proposition. So we certainly don't plan to issue equity to fund the CapEx.
Last couple of questions. Have you tried it on lithium clay deposits?
No, we haven't tried lithium clays, but it certainly is possible. Just in the same manner that lepidolite is possible. Just with lithium clays, like the ppm or the concentration of lithium is probably an order of magnitude lower than is in a spodumene ore deposit. So I suppose the low hanging fruit for us is obviously spodumene ore, and it was readily available here in our Western Australia backyard. So maybe for the future, lithium clays for sure. But right now the low hanging fruit is the much higher grade spodumene ore.
And from a recycling point of view, is the output a mixed metal or is it separated metal salts?
It'll depend on each particular application. So for lithium chloride, the output is lithium chloride. So we're going to aim to have that in a liquid solution, and the companies like Albemarle do sell lithium chloride solution as an end product. And with other metals, say for the likes of gold or copper, again, we'll be transforming those into metal chlorides. And it'll depend on the particular application, but we can have those in either liquid or solid form, depending on the subsequent steps that we do to them. But essentially, we're targeting the metal of interest in whatever the bulk waste or bulk ore that we're trying to pull it from, and then forming the chloride. And then we can either transform that chloride into something else. For example, lithium, we can transform the chloride into carbonate, and we will do some testing on that soon. So turning the lithium chloride into lithium carbonate, which is the battery grade product. So it's basically unique to each application.
I'll finish with this, which is probably more of a statement. Obviously, grants can take time, but you're very confident or seem confident of the ability to get them, non-dilutionary. The comment here is, given the great opportunity that appears with this technology, size of market, and the opportunity to move it forward, a number of shareholders have said, look, we'd prefer you to go to the shareholders and ask for the money if it means we can get there quicker.
Yeah, look, the CapEx, as I mentioned, for the pilot plant is very, very modest. The current estimates are like 3 million. So it's compared to what might be traditionally associated with these type of projects, it's very, very modest. So, but look, we're going to try and avoid equity as much as possible. But if we do need to do it, we'll do it. But yeah, as mentioned, there's lots of interested government funds available for this type of technology, and we're going to pursue that as quickly as possible.
Thanks, Michael. That does bring to a close the Q&A section. We got through a lot, so I appreciate, firstly, all the questions that came in. There were a stack of questions that came in, and Michael, thank you for diligently ticking them all off and getting through them and giving answers where you could. Really appreciate your time. Thanks, everyone, for tuning in to listen to the presentation, and to Michael for your presentation and, as I said, participating in the Q&A. Thanks, Michael.
Thanks, everyone. Appreciate it.
As I said, the contact details for the company are on the screen, and should you like to follow up with Michael directly, please do so. A lot of news to come, interesting technology. Share price already moving on the back of Michael's appointment and his experience in this area. Clearly a lot to follow, a lot to digest. Do your research, talk to your advisors, and have a great day. Thanks, everybody.
Thank you.